Hi, can you all hear me? Am I loud enough? Yeah. All right, it's still quite noisy, so I try to speak up. First things first, is there anybody here who speaks English better than German in order to avoid that we are just a cringe bunch of Germans talking in English? Okay, so let's stay with English then. I have 5 minutes less than I anticipated, so we're going to leave some topics out and rush a little. But in order to get a little feeling for the audience here, is there anybody who has experience in software development already? Nice. Who did use Kubernetes already? Nice. Okay, for the other ones, it's going to be tough, but you'll have a bunch of buzzwords that you can Google afterwards. I promise you that. Yeah, so welcome to my talk, The Power of Decoupling at IONOS Cloud. I'm Sebastian Sebastian. My meaningless title is Head of Service Integration. And my intention is to take you on a journey on our journey that we went through with a couple of technological and organizational changes that drastically accelerated our time to market when developing new cloud products. What is a cloud product? We at IONOS Cloud basically sell infrastructure as a service, which is virtual data center, servers, and so on, and platform as a service. For example, managed Kubernetes. At the beginning, we were coming from a set of which, in my opinion, I would consider as worst practices from today's perspective. And these, in my opinion, worst practices are, sorry to tell you that, the combination of Terraform and Ansible in order to manage your infrastructure and your configuration. In my opinion, that's just terrible. We had the operations department that were responsible for deploying software instead of the ones who were developing the software, which was a bottleneck always. And in consequence, also the operations department had to maintain security of the deployed software and not the developers who developed the software. Some developers which tried to make themselves independent from operations provisioned their own Kubernetes clusters in order to run their software in there and being able to deploy their software themselves. So development operated their Kubernetes clusters which kept them busy with operations instead of software development. And worst things last, API last. The specification of how to interact with the cloud services was defined after implementation of the software, which made all tasks that have to can be started when the API is specified, that they can only start at the end of the software development project, like the quality assurance, security, documentation teams, and so on. But once upon a time, we finally had a new service, managed Kubernetes, which led to the fact that now the development teams that wanted to run their software in Kubernetes didn't have to operate their own Kubernetes anymore, and once again had more time for actually developing their software. And also all the new products that we developed, or many of them, started developing their applications cloud native on top of Kubernetes. And if we take a look, since all that we do is provisioning services for customers, let us take a look on a couple of options that we have for provisioning services. First, some random workflow engine that makes sure that every task is done that is supposed to be there in order to provide the servers. Second, some stateless API service that give some context to the request, for example, for exposing internal APIs as customer services. An event bus where you just put all your jobs to be done into, and the systems that listen to the event bus react. And Kubernetes. I mean, Kubernetes is itself, Kubernetes' only job is to make sure that the services or the resources that you want to have are provisioned eventually. And unfortunately, Kubernetes originally was intended to deploy container-based resources and nothing else. But luckily, Kubernetes introduced the so-called operator pattern, which enabled us to use Kubernetes as a control plane for whatever the fuck we want. Like we could control our own coffee machine with Kubernetes if we want to. So let's explore a little Kubernetes operators like the teams back in the days did, which developed new products. And in order to do that, we have to understand a little of how Kubernetes itself works, because operators extend Kubernetes. Unfortunately, I only have a small screen. I hope it's big enough for you to read. But Kubernetes basically consists of an API that you can tell RESTfully what resources you want to have. You usually do that with an API client, like, for example, kubectl. So if you use kubectl, you interact with the Kubernetes API in order to create, update, or delete objects. Of course, you're also able to read objects, but this is not interesting for our use case here. If you tell Kubernetes to create a resource, it will remember that resource as it will remember that resource as an object that it will put into its brain, the etcd. And it has some desired state, but the desired state of the resource being ready is not accomplished yet, since it's not even started to provision this resource. Okay, these resources come from resource definitions of the standard resources of Kubernetes, like, for example, a namespace, a deployment, a pod. To each of these resource definitions, we have a correlating controller. Kubernetes has, for example, a pod controller. And this controller is executed again and again in a control loop. And with each execution, it's supposed to bring the resource one step further to being provisioned. That's what we want to do with our cloud products as well when a customer orders a new product, resource, whatsoever, right? So we use the operator pattern to extend Kubernetes. It's very convenient that Kubernetes also offers a resource which is called custom resource definition. You can use a custom resource definition to tell Kubernetes, okay, Kubernetes, please take care of my coffees. I want you to be able to create coffees. Okay, you tell Kubernetes you have now the coffee custom resource. Kubernetes knows that the resource exists, but it doesn't know what to do when the resource is supposed to be created. So you need your own controller, which in the context of Kubernetes is called an operator. And an operator is basically a workload, a pod, a container that you deploy to your Kubernetes cluster. And as soon as Kubernetes sees, the custom resource is supposed to be provisioned, your operator is part of the continuous reconciliation loop of Kubernetes and called until your resource is deployed. Your operator can then talk to the API of your coffee machine and make sure that all the coffees are prepared eventually. And if the coffee machine is busy, it will wait till the next reconciliation loop until the coffee machine is free again. All right, so coming back to the ways of that you can use for provisioning services that we already considered, let's check out when to use what from our opinion. This is like not a dogma. You can have your own opinion on that. But for stateless API service, the use case of a stateless API service for us is in synchronous requests. Means the request can be fulfilled in less time than, for example, the HTTP timeout of the request. So when I make a request against the API, please do prepare me a coffee. It's going to be a super fast coffee machine. Within a second, it's there. Then I dare to let the client wait until my coffee is prepared and tell him back, yeah, it's done. This in our product range, for example, works nice with DNS records because a DNS record is supposed to be created that quickly. There's nothing to be reconciled. But if there are some bursts, many requests, there's the chance that jobs will be forgotten. And the client, the service, and the resources are very tightly coupled. An operator is good for asynchronous requests. If things take longer, like provisioning a virtual machine, you can tell the operator, okay, you can tell Kubernetes, please, I want to have a virtual machine. Kubernetes will take care, and you can get the status of the virtual machine all the time. So how far is it? When can I use it? And if we have resources that need to be reconciled, for example, a certificate, like I had so many incidents because of expired certificates, and with a reconciliation loop, which makes sure that before the certificate's validity ends, it's going to be extended. We can sleep way better, especially at night when we are otherwise, because like these already expire at night, right? People work at night, they create them at night, and they expire at night, and things crash at night. And the third tool that we use is our Kafka event bus for events that are asynchronous and lead to actions that we cannot anticipate because products react to events and do things what they think is right according to that event. For example, customer has canceled the contract, all the products see that event and tear down the infrastructure that we have for the customer. We have no reconciliation here, so no attachment and coupling between the deployed resource and the request. But we have a very good burst protection. All right, so what happened? The teams started to use managed Kubernetes for their cluster. They deployed their own operator in case they needed one. And they exposed everything via a REST API that they set up directly to the customer. Before we had like a central API service and every provisioning process was behind. So everybody waited for the API developers to finally integrate and release a new product, a new feature. So this is then the new architecture, the simple one that we had. But when you have that, you want to do GitOps. Usually in Kubernetes, you do kubectl apply or Helm install in order to provision your software. And if you do that manually, this is something that you want to avoid. So you want something like, for example, Argo CD, which kubectl applies or Helm installs all the time to your Kubernetes cluster, so that as soon as there's a new version, you have your new version in place. But unfortunately, like every team needed this, so they started up spinning up their Argo CD cluster, and they wanted to have metrics, visibility, logs, and everything, and a place where they could store their images for the containers. And they had infrastructure to maintain again, and they were busy with operating the infrastructure again, and not with developing their own software. So still, we got rid of one of the worst practices because we were not configuring servers for deployment anymore. So Ansible was aware, so only terrible. Development deploys software. Nobody maintains security because operation doesn't have any idea of what's running inside of these clusters. And development operates the supporting infrastructure. So we introduced a platform framework, especially for these cloud-native services, and moved everything into the cloud native that was necessary for operating for operating all the resources needed for running and deploying the software. And development could again focus on developing their software, which is their main task. And Also, we replaced Prometheus with Victoria Matrix because it scales better. And we installed a bunch of operators, additional operators into the clusters that enabled everybody to do certificate management, secret management, because this is all the things that you just want to get rid of when you develop software. Which means now our platform framework operated the supporting infrastructure, which was a way better practice than before. One thing left, we wanted to get rid of Terraform. Terraform is infrastructure as code. You tell you want to have a virtual data center, these kinds of servers for your provisioning infrastructure. It has to be there. And we decided we don't want Terraform anymore, so we started to use Crossplane. What is Crossplane? It calls itself a control plane framework built on the foundation of Kubernetes to orchestrate anything. Sounds like an operator. And it actually is, but it is rather an operator framework, which makes things easier, which has a couple of nice switches, but also disadvantages. But you can just throw in all the resources that you want to have, and you have to take care. You have to take less care about the details of how an operator is supposed to work. And these resources, this bunch of resources, is called a provider, and we open sourced a provider that has all of our cloud services represented in Kubernetes resources. So you can install this provider to your cluster, and then within your cluster you have the resource virtual machine. You can use a kubectl for creating virtual machines, for example. Quite nice. So why Crossplane instead of Terraform now? Why is it better for our use cases, in our opinion, than Terraform? Because our softwares already were deployed with Helm. We had Helm charts, which is basically a Kubernetes deployment with some templating. And we had Terraform, which was some weird looking code. And we wanted to have all in one place, setting up our infrastructure and deploying our applications in order to have less complexity. And it has reconciliation by design, like no outdated Terraform manifest that you have to first adjust to the real infrastructure before you will be able to deploy it again, which you will never do again because you don't have the time to do that and do everything manually again. Okay, less worst practices. Terraform away and replaced by Crossplane. Not completely, because we have no Crossplane without Kubernetes, and we have to bootstrap Kubernetes before, so we all still have some Terraform code left. What's left? API first. Like I already mentioned, we have our API specifications separate from our code. We generate our code from that, and also all the other teams can start writing tests and SDKs, our Crossplane provider, our Terraform provider, documentation when the API is defined and not when the service is production ready, which decoupled this organizationally as well. But what about security? Because there are, I know operations which doesn't want developers to take care about security. We didn't either. So what we made use of is Dependabot, which manages our dependencies on GitHub and opens PRs as soon as we have outdated dependencies. CI/CD, I mean, we want to deploy right away. Already showed you that. Registry scanning, we scan all of our images that are in our registry for current CVEs. And we scan also our workloads in the clusters, because you never know what's running in your clusters, and create bill of materials with CVEs. So we know now what's going on, and as soon as we have these CVEs, we can go to the development teams and tell them, fix that. So your takeaways, hopefully: fight terrible mutations, go immutable, go operator, go crossplane. If you're a development team, don't operate your Kubernetes. Kubernetes is fast. Generate your codes. Go API first. As a development team, you build it, you deploy it, you run it, you own it. You have to fix it. Of course, this product orientation comes with some additional challenges, which are project generation harmonization, new product, new platform framework, the ones that have their own secure vault for secrets, the one that use the one from the platform framework, and then you have to find time in order to harmonize everything, otherwise it's a mess. Standardization, one specialist per team, they all have an own idea on how to do things, to do the same things, believe me. And incident and change coordination, it takes time until you find the right team which can fix your issue, but you will find it eventually. And knowledge sharing. You have to make sure that the people talk to each other. You're isolating them in their product environment. Thank you. Any questions? Yeah. I'm just going to give you the microphone.
How are you configuring your hosts when you dropped Ansible?
Yeah, that's a good question. I left out a lot of details here. We try to avoid having hosts. Like from a developer's perspective, it's all cloud native, it's all container. If we have hosts that we depend on, for example, databases and so on, we try to rather go an immutable approach, start everything from a new image with updated software and so on, instead and a new configuration, instead of maintaining updates and configuration all the time, which will eventually lead to diversion. Yeah.
Yeah, but there's also some compliance on your Kubernetes nodes you have to assure, right?
Absolutely. We have maintenance intervals, and these Kubernetes nodes are rotated by our managed Kubernetes, and Kubernetes makes sure that the resources are moved before one node is taken down, but we enforce that our nodes under the cluster are up to date. We also enforce that for our customers, we enforce that for our developers. Anybody else?
I have two questions. The first one, what do you use for image scanning? You talked with the registry. And the second one is you told that the operator can manage everything, such a coffee machine. And I think, can I manage executables, like Go executables, or in the next step, Windows executables?
Image scanning. I should have an SRE here. I'm not sure if that's a function that our Harbor already provides the image scanning, or if they put something in additionally. I think it's a feature of Harbor, but before I embarrass myself, I'm not 100% sure what we use there. It's the SREs. And for the second question, operators can be used to manage resources. An executable is not necessarily a resource. Of course, like an operator is a Go executable. It's like software that is executed in the control loop. So I don't know if I understood your question correctly, but we can go into that deeper after the talk if you like. Anything else?
So you mentioned you went open source on a connector or somewhere else. How was your experience going open source when it comes to licensing, when it comes to publishing and anything around going open source? The question was, how was your experience going open source in a project, about licensing, about distribution, about documentation, about anything around going open source?
I mean, we have departments, legal departments that take care of that, but I'm not 100% sure under which license our cross-plane provider is. But still, customers are free to use it. I don't know if how good the contribution works, because basically we offer the provider, and if somebody opens a pull request that fixes something, nobody would say, oh no, we don't want your code. But in terms of licensing, there's a specific license for the open source tool that we use, and it's a quite open license. I'm not 100% sure which one we used, to be honest. Anything else? No, it was the last question I was just told. So thank you for listening. It was fun, a pleasure.